Now on the stage we will have a person that, well, we talked a bit about it for a second and we decided that the introduction will be short and simple. Smart guy with glasses. So Gil Tayar, please come up to the stage. He will be talking about front-end testing and, well, I hope it is such a great presentation. Even I will understand what you're talking about.
Who knows? Well, I'd agree with the glasses. The smart, well, tell me after the talk. Okay, front-end testing, mapping out the territory. We're going to talk about front-end testing in these 45 minutes. First of all, a little bit about me. I go way back to the 80s, really old. I've never done I did a little bit of the management thing, but didn't really like it. So basically, I'll probably die a developer. One of the two things I love at these times is testing, which is why I'm here. Most of the code that I write is fully tested. Sometimes even the code that I write for talks, I test even that, which is crazy. I'm currently an architect at Round Forest. Please ignore the last bullet about if you want to come work with us, because Lithuania and Israel. Oh, I'm from Israel. Okay, there are 10 kinds of people. Those that understand binary and those that don't. There are two kinds of developers. Those that are confident about the code they write because they test everything, and those that aren't. It's that simple. I went to Wikipedia to see what software testing is, and didn't like what it's written. And for me, testing is an art. It's never. There's always a discussion about what is development. Is it craft or art or engineering? For me, it's more of an art and a craft. Is the craft of ensuring that changes in the code will not cause new bugs to appear. Testing is confidence for me. I know there are other reasons that people test. We'll talk a little bit about them. But for me and for the rest of this talk, testing is about gaining confidence that what we write is correct. And why? Why do we need that confidence? Because we're shit, really, seriously. We don't know how to write code. This is my former CEO back in the days. He said that all software is a harmony of bugs, which is true. We all know that it's true. I mean, it's not that there aren't any bugs, it's that they work together very nicely. And to understand why we're very bad at what we do, let's see how developers like us work. We sometimes add code, and when a manager thinks about adding a code, they're like, yeah, just put in the new feature, right? Just like Legos. And we know that the truth is like different, a little bit different than that. We add code, we break a lot of other stuff. Same for removing code, especially if you're doing CSS. Oh yeah, let's remove that CSS rule, right? And it looks like a surgical precision kind of a thing where you just remove that line and nothing ever changes. But we all know the theory. Yeah, well, let's just remove the if. It doesn't matter anymore. And then you deploy to production and boom, we're dying. And refactoring, yeah, let's get this big function that does lots of things and refactor it into little stuff and everything. But we know how we start refactoring. We never know how it ends, which is, yeah, we know that, we're developers. So what do? And the answer is we test. And there are two kinds of testing, one which I don't want to talk about and one which I do. One that is called QA testing, done by QA, and the other is developer testing. A little bit about QA, I call it throwing things over the wall. The developer codes and he codes and he writes the code and he runs tests manually to make sure that it works until it does. And then he throws it over the wall to QA. Quality assurance. This is a beautiful, I love it. It ensures quality. That's what it says in the name. And so on, this cycle of writing code, throwing it over the wall, QA testing it, finding bugs, and it's a very, very long cycle. And remember, whenever we do things like adding features and whatever, we have to test the whole app. We can't just test a little bit about it. And QA, and this turns QA into a gatekeeper, into something that blocks the what should have been a frictionless process of writing code and deploying it to production. They're there and they block it, and it takes time for that blocking to unblock or to remember. That cycle takes so much time. What's the solution? For me, it's, well, getting rid of QA, which is not true, right? But for the regular flow of development, it is getting rid of QA and replacing it with developer testing. And we know the best developer is lazy, and given a repetitive task, we automate it. And the idea is for the testing, and a lot of, back-end people, for them, it's like almost, yeah, of course we do testing. Front-end testing, less so. And we'll talk about that a little bit. But we have to make testing, even in the front-end world, part of the development process and not something that we do later. So the front-end developer codes, she codes, and she writes the tests for the code during the time she codes, before, after, I don't care, but as part of the development process. And while coding, she runs the tests and ensures that they run until they work. And that's it. And whatever she adds codes or deletes codes or whatever, she reruns the tests, and great success. And a lot of people ask me, okay, yeah, but how much testing? And I checked a lot of times, like every time I do a testing talk, I check the amount of code in my app versus the amount of testing code in my app. It's called production code versus testing code. And the answer is usually 50-50. Sometimes 60-40, sometimes 40-60, but around the area of 50-50. Half of the code I write is testing code, and it makes sense if you think about it. And it's been mostly consistent for the last 4 or 6 years. What does it give us? It gives us 3 things. Testing gives us confidence. It gives us confidence. And it gives us confidence. Testing gives us confidence in what we write. There's another reason for testing, and it's what is called TDD, test-driven design, where testing enables us to make sure that the design is the correct design. I don't want to get into that. It's a whole religion, not a huge fan, but I definitely understand where they're going. As long as they agree with me that it's also for giving confidence, I'm okay. So, why doesn't everybody do testing? We know. Testing is hard, and we're lazy. Let's face it. And the weird thing, and the more problematic thing is that managers, I hate that, don't give us time to do testing, and that is wrong. The other one. I mean, if you're lazy, fine, but if managers don't give you time, well, they shouldn't. It's part of the development process. It's not up to managers to say how much time you write code and how much time you test. It's the same thing. I've never told my manager it's going to take me 2 days of coding and 2 days of testing. I just say it's going to take me 4 days. Okay, so let's cut the bullshit. How? How do we do front-end testing? This was a motivational thing to get you excited about testing. How? First, we'll talk about the types of tests. What kind of tests do we have? And there are 3: end-to-end, integration, and unit. And usually, overviews about these 3 tend to go up the ladder. So first they explain unit, then integration, and then end-to-end. We'll go down. I don't know, it seems more natural, and I like to do things a bit differently. So we'll start with end-to-end testing and go to integration and then finish with unit, because it's the simplest. And a lot of times when I ask people, do you write tests? They say, yeah, we have lots of tests. And I ask them what, and it's mainly unit. And as we'll see, units are the least important tests from my point of view that you need. Okay, let's go. We'll start with end-to-end, as I said. There are so many tools out there. We'll show Cypress. You could use Selenium WebDriver. You could use Test Cafe. You could use what I use today, which is WebDriver.io. Doesn't really matter. They're basically mostly the same. Let's use Cypress. So, and the app we're showing is like the To-Do MVC. A lot of You probably know it, where you write to-dos and you can check them for when they're done, and you can delete them and whatnot. We're not going to show it, it's going to be, but just so you get a context of what we're testing. By the way, there's a GitHub repo with everything here, all the tests and everything. And the last slide will show it if you want, and you can take that picture and see it. So what do end-to-end tests test? That's a difficult one. Well, they test everything from the user's point of view. So you basically run the app, open a browser, unautomate it, like click this, type text here, all that stuff, and then check the results. So click on write to do, press enter, and check that it's in the to-do list itself. It's that easy. So let's write the test. First of all, navigating to the page, and this is assuming that the app is running. So what you usually do when running a test, when doing npm test, is in the background also run the app. So once you run the app, you can visit the page in Cypress using sci.visit. Okay. Oh, first of all, the it is a test. So you can have multiple tests, and it should navigate to the to MVC, and then in the function you write what you're testing. So this test just visits the page. If the page doesn't work, you'll get an error. But this is really a good test. So sci.visit, sci is the global Cypress variable where you can access all its API. Let's do something more interesting. After we visit the to-do MVC app, we get an element using sci.get. You give it a selector, in this case .new to do for the new to do input, and you type into it. And you type into it. We'll skip that timeout. And you type into it clean room and enter. So it'll type clean room and do the enter. Very, very easy, very nice. And then you get the toggle button. Okay, so after you do an enter, a to-do appears. Then you get the toggle button, and you click on it to mark the to-do as approved. And you can check, and instead of sci.get, you can say sci.contains if the button has something. But that's nice, but how do I check that whatever should have happened, happened? And the answer is validation, okay? If you want to check that some element has some text, so you do sci.get.label, that gets the label of the text, and should have text clean room. Other stuff you can do is check that some things should have CSS, because when you toggle the button, it shows a strike through. So you have to check that the strike through is there. And the to-do list, after we clear the to-do list, should not have descendants. Cypress is very, very rich in all the validations that it has. Really, really rich, probably the richest one that I know. Try it out. I love Cypress. I'm a huge fan. So we said that we want confidence. So don't worry. Cypress and others like Selenium and WebDriver.io have you covered for end-to-end tests. So now we can refactor our code and delete code and add code with impunity, right? We just add it. We just add the code, delete the code, refactor, run npm test, and voila, we're fearless. We don't fear our code anymore. Are we? No, there's a little problem. Our tests are functional tests. They can test that the app works functionally, that the user can input and click on the to-do and everything, but how does the application look like? We don't test that. I mean, if we forget the link rel equals style sheet, you just forget it and just show raw HTML, like without styling, the test will still work. But obviously, we can't ship that, right? So we have to test the visual aspects. And this is the biggest difference between back-end testing and front-end testing. Back-end testing doesn't have any visual aspect to it. Front-end testing, very much so. So why do we need it? Well, we've seen the page, it's okay, but what if we change the CSS and the HTML? Our test will still pass, and yet we have a problem. And we know the problem CSS has. I looked for memes about CSS, and these are the ones, we all know them. I learned to create a website, add HTML to it, everything's fine, add CSS to it, and boom, One does not simply know hell until they've tried web development with CSS. Do CSS, they said. It will be fun, they said. More. There's so many. You just write CSS memes, and they're all bad. They're all, and for me, the most important one, I looked a lot of them, and this struck the biggest bell. Make a small change to the CSS, and my website looks like that. And we know that. It's because CSS is a declarative language, a small change can have a big effect, and we don't know. If we remove an if, we can sort of understand the consequences. In CSS, we think we sort of maybe, I don't know, probably not understand the consequences. That's how CSS works. Unless you're Rachel Andrews or one of those CSS, Lea Veru. Okay, I hope I've convinced you testing CSS, HTML, testing the visual aspects is important. So what does testing it mean? When we test a page manually, we look at it and we say, yep, right, correct, according to spec, works. Can we automate that? And the answer is no, at least until we have highly intelligent AI that can look at a page and says, oh no, this is wrong, which is who knows if we'll ever have that. We can't make the testing tool look at a page and say, yes, this is right or this is wrong. We need a human inside. But what we can check, and that is what all the visual testing tools do, we can check that what was still is. We do visual regression testing. That's the only kind of testing. All the tools do the same thing. They check that nothing has changed. And how does it work? You write your browser test, click, 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 and then you say, okay, I want to test now this page. So you take a screenshot using the tool of your app, and the app compares it with a baseline image. The first time the test runs, it says, okay, that's the baseline image. The next time the test runs, it's compared, the current screenshot with the baseline screenshot that was in the first test. If everything's fine and it's the same, we're done. Good, let's continue on to the next test. If there are any differences between the two screenshots, the tool reports the differences and fails the tests. Now, the big question, which is has been the big question, is it a bug or a feature? The testing tool doesn't know. Did the move of the button, did the button move because it's a bug in the CSS, or were we meant to move it? Which happens, it's visual. So you as a human need to accept or reject the difference. If you reject the difference, fine, it's a bug. The test failed anyway. But if you accept the difference and rerun the test, that screenshot becomes the new baseline. So if you rerun the test, everything works again. This is how all visual testing tools work. And the main difficulty, caveat. I used to work for Applitools, which is a visual testing tool company. So no problems there. I used to work, I don't work anymore. But in the current company, Round Forest, we needed a visual testing tool. And because I think it's the best tool out there, I bought a license for the company. But just so you know, caveat, this is where I worked. And the main difficulty in this process, there are two difficulties. It's the accepting rejection and looking at the diffs, but the main thing is comparing the screenshot. And it's a problem, because look at these two screenshots. Look the same, right, for the naked eye, human eye. But look at that. One is like this and one is like that. One is this Windows machine and the other is that Windows machine. Or maybe one is Chrome 94 and the other is Chrome 95. These little differences appear again and again and again. And if we have a bad comparison algorithm, we get lots and lots of false positives. False positive? Yes, false positives. Everybody knows what false positives are these days. This is so fun. The difficulty is, so that's one thing you should look out when you're looking for a visual testing tool. Currently, Applitools is like by far the best one. The others do some kind of pixel matching, pixel differences, and get lots of false positives. But the difficulty is also in the UI that you use to accept or reject, because sometimes one change in your CSS, a good change, and you get and you have 30 screenshots and you get a lot of things to accept or reject, and you need to check them. So you need a good UI that allows you to accept or reject the changes. And there are many toolkits out there. For me, the two best ones are Percy and Applitools. Don't even think of using the open source ones. They're really nice. I love them. But in the end, you really need a commercial tool for visual testing. Unfortunately, there's no other way. It's the only place that you really need power here. And only currently, Percy and Applitools are the ones that give you that power. So how does it work? Let's start coding. So to do actions, we're going to check it visually. We're going to check the to-do page visually. First of all, as usual, we visit the page before each test. And also we do an eyes open. This is using Applitools. Eyes open is like start the test, initialize it, give it a name and whatever. We're not into and side.eyes close closes the test. And then we write a new to do and press enter and check the windows. Oh, sorry, no press enter. We just write clean room and then check the window. What does check windows would do? We saw that. Writes a screenshot, compares it, does all those things that we talked about. That's it. It's that easy. A lot of people also prefer doing. Well, let's talk about that later. If you want to do 2 screenshots, no problem. You, for example, do 2 checks window, one with no to-dos and one with 1 to-do. You can do as many screenshots as you like. Just as if you're going into visual testing, don't do too many. Don't do too few, but don't do too many, because checking all those screenshots again and again and again is a pain in the butt. So let's change some CSS and see how it works. So we go to some line, change the CSS, and yep, this is Applitools. The change is detected. It shows the baseline. It shows the checkpoint. It shows which, it marks the changes in the text. And I can accept or reject with a like or a dislike. That's a nice touch. And we need to do it for all of them. And at Applitools, you can use some kind of AI visualization algorithm, and it groups all the changes together so you can accept or reject them at the same time. This is very cool. But we live in a responsive world. We do responsive design in the CSS. What we tested was one browser, assume probably Chrome. Well, it has to be Chrome if you're using Cypress, and just one form factor, whatever, 1024, 1280, just one width. And we know that visually we have mobile and tablet and this, we have 3 or 4 breakpoints where the UI is totally different. So do we need a grid of machines that run Safari, which is crazy, and Firefox, and run the tests in this form factor and that form factor? And the answer is no. Currently, Percy and Applitools have something called Visual Grid. And what is a visual grid? First of all, remember, the web is open. HTML is an open standard. And if you view source, okay, you can see the HTML of the page, or if you use DOM. And that means that we can take any page as it is and recreate it somewhere else. Like we can teleport the state of the page exactly as it is without any JavaScript, just a DOM as it is to somewhere else. And I'll explain, just like save as in the browser, but more importantly, more high fidelity. So we call that a DOM snapshot. It's a snapshot of the DOM as it is. And instead of taking a screenshot we take a snapshot of the DOM and the CSS and the images and the fonts and the SVGs and the canvas, and I think that's about it, but maybe I lost a few. We take all that and upload it to the visual grid, whether it's Percy or Applitools, where we store the DOM snapshot. Once we have that DOM snapshot, we can recreate the page in the background and run the page, there's no JavaScript in the page, it's just the page as it is, but show the page with Safari, Firefox, this form factor, all the form factors that we want, and run it in parallel across all these form factors and across all these browsers, and take screenshots in parallel. This is great. So we extract the DOM snapshots. Whenever you do a sci.eyes check window, whenever you take a screenshot, you're actually not taking a screenshot, you're taking a DOM snapshot. We upload the DOM snapshots to the visual grid, not us, but the tool, recreate the DOM snapshots in parallel in the browser, in the background, and take screenshots. So, this is perfect. We run the test once, probably on Chrome, and we get screenshots that are tested for differences in the various form factors and browsers. So you run the test once and validate on many form factors. This is crazy. And it's so easy with Applitools or Percy. You just specify what the browser configurations are. You say width, height, type of browser, and these tools just make it work. One important thing is all layouting must be done with CSS and HTML. If you use an on-resize kind of JavaScript, which changes the DOM based on the size, that won't work because we're not running JavaScript in the visual grid. So all layouting must be done with CSS and HTML. If you're doing responsive design, that's great. So now, finally, we can refactor our CSS and HTML with impunity. We just add, delete, remove HTML and CSS, run npm test, and we're fearless, even on our HTML and CSS. So we're good. We're good visually, we're good functionally. Applitools and others have got you covered. Okay, integration testing. So, all good? Are we done? Can we go home or whatever, have coffee? Easy. That's what I said. Write a lot of end-to-end tests. What do I need all the other kind of tests for? Just run a lot of end-to-end tests and we're good. And that is what a lot of people do, especially QA, because QA has no other option but to run end-to-end tests. But we're developers. We can do others. But why? Why do others? Why not just end-to-end? And the answer is, there's so many answers. I hate end-to-end, really, seriously. We'll talk about it in a second. They're very, very slow. If you want to run hundreds of tests, and you should be running hundreds of tests, it just takes tens of minutes. We can live with that, but they're flaky. You cannot run 100 end-to-end tests and have them all pass. It just doesn't happen. Not because there are bugs, it's because browsers are flaky and servers are flaky, and combining the two together just doesn't work. And there are lots of ways to mitigate that, but I've never seen a foolproof test suite that does hundreds of end-to-end tests. Never. Never. And they're difficult to debug and troubleshoot because you can't really access the code. It's like source map, and it's very, very hairy. You can, but it's difficult. And it's not local. You can't test just this part of the code. And that is the most important thing, or just that part of the code. You have to test the whole app. So if you're trying to modularize your application, you can't modularize your tests. And that is very, very bad. We need something that is fast and easily debuggable, that can test only parts of our application, and I have just the thing. Let's start the journey to JSDOM. Let's skip that. Let's take a very simple, and we're talking about integration tests. Let's take a very simple counter app. Body, H1, root, a script source with DOM counter, and /body. Very simple. How do we... Did I miss the counter thing? Yeah, and there should be the counter HTML itself, sorry. How does the app look like? This is vanilla JS, but it could be in React. You do a get element by ID, get the counter value, the element, add listeners on plus and minus for the clicks, and when the user clicks on plus, you do +1, and if the user clicks on minus, you do a -1. That's the counter app. Very simple. If only we could do this when running under Node.js. If only we could, like in the before part, just require the DOM counter code, and then click using click on the element, and then check that its text content is 1 or 2 or 3, whatever. If only. But we can't do that in Node.js, and to run it in the browser, we saw it's slow, it's flaky. Why can't we? Because it's Node.js, there's no document, there's no window, there's no anything. And that's where JSDOM comes about. JSDOM is just a DOM implementation in JavaScript in Node.js. It just works just like a browser without the visual aspect, without a lot of aspects of the browser, but for 99% of the cases, it just works. So let's do that. Let's require JSDOM and create a document using a new JSDOM. See, we get the root and get the document. And this document is just like the document in a browser. So we can do a get element by ID, get the text content, and console log it. Very, very simple, just like we're running in the browser. So how do we use this for testing? First of all, I create a global window and I create a global document. Okay, I put it in the global area because the application doesn't know that it needs to access window and global as local variables. They assume that document as window are global. So we just globalize them and then require the code of the app. It doesn't matter how big the code of the app is, it should work. And then just fire away. Click, test, text content, and it really just works. React works, and we'll see that when we get to the component testing. It just works. So go for it. JSDOM has got you covered. There are tons of articles about JSDOM and integration. Kent Dodds is a big proponent of that, and I urge you to read his detailed articles about it. An alternative that I want to talk about, and don't want to talk about, is Cypress component testing, where you can use Cypress itself to run your little tests in the browser. This is mostly new. Looks really nice. Okay, there's a specific kind of testing that is good only for front end. It's component testing. It's testing on one component, and you do have a component library, right? A library that has all the components of the app and is separate from the app itself. Some people do, some apps do, some apps don't. And a component library is usually like this NPM library shared by multiple apps. A lot of people use Storybook to show the components in the app. And it's independent or semi-independent. It's built independently, tested independently, and published independently. And the most important thing is, how do we test such a component library? Because it must be tested independently. And again, we need to do functional and visual tests. Let's skip the mock pages. Functional tests, this is React. If you don't know React, then just ignore me for 1 second. I just create a component, but it's the same for Angular and Vue, by the way. You create and you show this based on the click. And this is another way of using JSDOM, using the React testing library that Kent Dodds wrote. You render the component using the React testing library. It just renders it using JSDOM and React. And then, you expect this text to be null or that text to be null, and you can click on stuff and do all kinds of stuff in JSDOM. So this takes care of functional testing, just like JSDOM testing. It's the same. In terms of visual tests, you're even more lucky, because if you have a storybook, Applitools and Percy just say, give me the storybook, we'll create the tests for you. And we're done. Sorry about that. I thought I had it on mute. Okay. Let's talk about unit testing. The the one thing everybody has. Sorry about that. There we go. Unit testing our logic. Everybody has unit tests. And as we'll see, I'm not a huge fan, but sometimes it makes sense. So we want unit tests, and there are good cases. Unit tests, first of all, what are they? They check just one unit, one function, one class, one module, and they're wicked fast. They're even faster than integration tests. I love unit tests in that. They're like milliseconds or even nanoseconds time. And the beauty of a unit test is they can check many permutations. My best example is validate email, a function that gets an email and returns like true or false, whether the email is valid or not. We don't want to use end-to-end tests for that. We don't want to use integration tests for that. Why not just check validate email across all the 100 permutations of valid and invalid emails? And that is exactly what unit tests are good for. So let's use the store. The store is this business logic component that has nothing to do with the UI, and that's where we add the to-do and remove the to-do and etc. etc. So it's a perfect candidate. We could check it through integration, but if we want to check all the permutations, adding one in the middle, adding one in the end, deleting one in the middle, all those kinds of permutations, we could check it through integration, but it makes more sense to check it through unit. So this is a test. So we create a new store because the store is a JavaScript class, and we do an insert using the API of the store, and then we check whether the store, if we find that, then that element is there. It's that easy, and that is why a lot of people like unit tests, and that is why a lot of people have only unit tests. They're easy to write, easy to understand, and have somewhat good value. So we're good. Mocha and Ava and Tape and all those test runners that we use have got you covered. So we've seen all the tests. They're end-to-end, visual, integration, and unit. Those are all the kinds of tests we have. But how much? How much for each and every one? What's the strategy of tests? How much do I run for each? We've seen all of them. There are two main schools. One is the classic, I call it old school. It's the pyramid. The pyramid says lots of unit, less integration, and very little end-to-end. And the diamond school says little unit, lots of integration, and little end-to-end. And let's talk, and Ken Dodds has the trophy of testing. He's this front-end testing guru, but trophy is what I call diamond. It's the same thing. Why are there two, and what's the pros and cons of each? In both cases, the higher you go up, okay, the slower the tests become. Unit are wicked fast, integration tests are fast, and end-to-end tests are very, very slow. On the other hand, the higher you go up, the more confident you are. And unit tests may tell you that validate email works, but it doesn't tell you that the application as a whole works. It doesn't test you that all the units are glued together correctly. So they don't give you a lot of confidence. Integration are like in the middle. So in the pyramid says the most important thing is speed. And because we want speed, we want as many unit tests as possible. Integration, the diamond says, yeah, that's true, but we don't get a lot of confidence. So let's do the middle ground where we get a lot of speed. Integration tests are still fast, but we gain a lot of confidence when we do integration. Notice that in both cases, end-to-end tests are like as few as possible, which is better, and it's a religion. But in the front-end world, they're slowly or quickly understanding. Most people do diamond, or what's it called, trophy, or there's the third one, hexagon or whatever, I don't remember. It's the same. It's many integration tests. That is currently the best practice in the front-end world. And I'm a huge fan. You won't see me using pyramid. Let's talk about each one of them just to remind you and see how it fits in the strategy. Unit tests, whether they're using JSDOM to check one component or just using a regular code to check business logic, use sparsely. Only when you have to. They're very easy to write, so they're like a drug, but they don't give a lot of value. Well, just like drugs. Interesting. I use them only when they make sense. When you have something that does lots and lots of permutations, then they make total sense. Use them. Test permutations is the sweet spot for unit tests. Integrations, yes, use them, use a lot of them. You don't have to test the whole app using JSDOM. You can test just one page or one modal or one tab. You can choose the locality of the integration test, and that's so wonderful about them. Don't do too small, and definitely don't do too big. I've seen places where they do integration tests of the whole app. That is not a good thing. Try and localize on something that makes sense. Page is always a good one. Tab is great. Don't do the whole app. End-to-end. What can I say? I hate it. They're so heavy, so flaky. You need a server. Use sparingly. Have one. It's important to test at least the app, like in a happy path. Have one, test it in a browser, it's important. And some tests must use a browser because JSDOM doesn't support them, so well, what can you do? Use end-to-end. And visual, crazy important. Use them just as part of your end-to-end test. While you're going through the app in the happy path, just take screenshots and you're done. Visual testing configuration, you'll get a link to this, but this is what we use at Round Forest. It's been battle tested for the last year. Chrome in 1280, Firefox 1224, Safari in iOS and iPad, and a Galaxy Android just to make everybody happy. Don't forget production tests. After each deploy, what we do is we do a small end-to-end tests in production, go through the happy path. And the nice thing about it is we use visual tests because visual tests are so easy. You don't have to assert anything. You just have to take screenshots and make sure that the app didn't change. So we use that for production tests. It's great. That's it. Summary. Oh, yeah. I have this tradition in all my testing apps. Now everybody knows this. Somebody knows what this thing is? Dune. Yes. Now everybody knows because the film is out finally. It's called The Litany of Fear. And tests is exactly that. Tests enable us to not fear our own code. Do not fear to deploy. And that is important. So I will read it to you. A lot of times I say I have people rise and call, but not today. So I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will test my code. I will permit it to pass over and through me. And when it has gone past, I will turn the inner eye to see its path. Where the fear has gone, there will be nothing. Only my tests will remain. Thank you very much.
Well, we do indeed have a question. Before that, do we have any questions in the audience? Not yet. Yes, we have. I must be blind. You're very far away. Let me come to you in a minute, okay? We have a question from Oshara online. She's asking, hello.
Hello.
What are your thoughts on peer programming, where one would write code and the other would write tests simultaneously, rather than one developer doing 50-50?
As long as you write tests, it could be 400 people on the same code. I'm not a peer programmer. I've never done it really, but as long as there are tests, I'm happy.
So your thoughts are liberal. Okay, I'm going to that guy or girl. Actually, I wear glasses, but just for style, apparently, because I cannot see. Could you raise a hand one more time? Where was it?
Hello.
Hi.
Thank you for presentation.
Thank you.
What about just snapshot testing? And how could you group it into integration or unit testing? And how it can slow down the development because of this very detailed snapshot?
I'm not a fan of snapshot. I use it only when I have to, like when there's this, what I get is a huge JSON and I have to test it. So, okay, but most times when you click on a button, you want to check that, that the strike through is there or that the element is gone or whatever. That is easy to assert. Just lazily writing the whole HTML as snapshot test, when that test fails, you don't know why it failed. And that brings you to lazily say, yeah, that's okay. And basically make the bug legal, which is really, really bad. I'm not a big fan. Sometimes I use it, but the default is not to use it and use it as less as possible.
Okay, we have a question from Anja online. Is there any good way to write VE test in TDD ways, so tests before code?
To write what?
I don't know. I might pronounce things
Front-end tests in a TDD way, so tests before
VE.
code. Sure, I'm not a big TDD expert. I'm not even an expert. I'm not even into TDD. But why not? Code is code, especially today where like React, Angular, JavaScript, Vue, it's code. So TDD is definitely a possibility even in front end, yes.
Okay, one more person in the audience. That's lovely. I will ask you to stand up and take the microphone. We would like it to, your sound to be recorded online too.
So, let me lean over. So, my question would be, whenever we have, or actually even rather before we have a lot of tests for our big code base, how do we make sure that our tests that we are going to be writing are going to be maintainable when the amount of tests with the code base grows a lot?
So basically what happens when the app grows a lot and then you have lots of tests, how are they maintainable? That's a big question. I have a lot of answers for that. There are no easy answers, but basically write as few tests as possible. First of all, that's very, very important. Write as few tests as you can to feel confident. That's rule number one. There's this quote: write tests, mostly integration. Write tests as few as possible, mostly integration. It's a huge quote. I love it. The other is to modularize. Okay, so don't. If you're doing end-to-end tests, then you have 1,000 tests and they're all in one folder and it's a hell. But if you're writing code and your code is organized into folders and modules and packages, have the test as locally as possible to that code. So now it's not just one huge test suite. It's like little code here, little test, little code here, little test, etc., etc. That's what we use at Roundhorst. We modularize, just like we modularize our code, we keep the tests of that module in the same place. That is like the best strategy to do that. Yes.
Okay, anyone else from the audience? No, that's enough of the questions, it means, and that's all.
Thank you very much
for coming. Thank you very much for sharing, Jill. And I said Jill for the first time.
I noticed.
For the first time.
She got me right, and well, that's okay.
Yeah, because in Lithuanian, your name is Gil Tayar, like literally how it's written.
Yep.
And I turned my English on inside.
All good.
And now it's Jill. Okay, Gil.